Hello world, Lisa Friedrichsen here, your friend and computer science professor with another short screencast from javascript.info, the modern tutorial. We are down to section 5.2, numbers, and we're going to learn more about the number data type. And this time, instead of using a little sample web page that's connected to a JavaScript page in Visual Studio, I'm just going to look at this tutorial and right-click the web page in Chrome, go to Inspect, and I'm going to use my Console tab in my inspector to just play with the JavaScript examples that he is demonstrating. In the first part of the tutorial, he talks about more ways to write a number than just one. For example, we could create a variable named billion and assign it to 1 with 9 trailing zeros, or we could create it using the E shortcut, which means 1 times 10 to the 9th power. Similarly, we can write very small numbers. We could write ms, you are assigned to 0.000001, or we can say ms, you're assigned to 1 times 10 to the -6th power. There's also ways to write hexadecimal, binary, and octal numbers, and ways to convert them back and forth if you have that need. In addition, there's ways to convert numbers to different bases, base 16 for hex, base 2 for binary, base 36. If you need that functionality, it's there in the language. There are 3 areas here, though, that are very common and very important that I want to focus on. And the first is rounding. And he shows us 4 different ways to round numbers using the built-in math object and 4 different methods: floor, ceil for ceiling, round, and trunk, which is evidently not supported by Internet Explorer, so I wouldn't recommend that one. But he gives us a table on how this works on various numbers, and we can practice that in our console. So for example, if we use the Math.floor method and put in 3.1, we see that the floor method moves that number to the left on the number line to the next integer. And it works that way with negative numbers too. With floor, we're always moving to the left. The next floor to the left, the next integer to the left of a -3.2 is -4. Math.ceil for ceiling works exactly the opposite. It moves to the right on the number line, and that's pretty easy to figure out if we're working with positive numbers. The next positive integer on the number line from 4.1 would be 5. But it's a little trickier when we're working with negative numbers. If I have a negative 4.1, the next integer to the right is a -4. Math.round does exactly what you would think it would do. It rounds that number to the next closest integer. And so 3.1 is going to end up being 3. But how about 3.5? That rounds up to 4. We're rounding a negative number. It also rounds up to the right. So math.round works like math.ceil at 0.5 and above, and it works like floor on less than 0.5. The next important topic that he talks about is how to convert a number with a large number of trailing digits to 2 digits after the decimal point. Because after all, we're going to be working with JavaScript a lot with dollars and cents. And so we're always going to want to calculate correctly to the nearest cent. First method, I'm just going to copy this into my console here and run it, will alert the result of this expression. And as soon as I press enter, I'm alerting 1.23. Now let's figure out exactly how that was calculated. So the num is 1.23456, and we're multiplying it by 100. So that takes us to 123.456. Then we're taking the math floor of 123.456, and that takes us down to 123. Then we're doing our last operation, which is dividing by 100, and that takes us to 1.23. That is the way I was taught to do this. He teaches a better method, though, and that's the toFixed method. And so I'm going to let num2 be assigned to 12.34 and just work on it in the console here instead of using these alerts. And so he shows us that if we take the num2 and we use the toFixed method, then we can feed it a number of digits that we want to remain after the decimal point. So if I say num2 toFixed 1, he's going to round that number to 12.3. Num2 toFixed 3, he's going to add on a trailing 0. And in both of these instances, notice that when we use the toFixed method, we are resulting in a string. And sometimes you want that, because if you had a, let's say, num3 and I'm going to assign it to 5, then you might want that 5 to show up as 5.00. So num3.toFixed 2 is going to show up as 5.00, exactly what we want to display. So the toFixed method does return a value with the number of digits to the right of the decimal point that we want. And if I have a number like this with many digits to the right of the decimal point, when I use toFixed, it rounds that number. Let's try it one more time with a number 2, 3, 5, 6, 7, 5, 6, 7, 8. Let's prove one more time that toFixed rounds. And we see that the number 5 was the 578 would round that number up, and toFixed indeed did round the number up. Now, it always spits out a string, though, at the end. And so he tells us that there's 2 ways to convert that back to a number. We can use the plus sign to convert the entire value to a number. Or if we want to make it a little bit more obvious, we can wrap that number with the number object. And both of those will then do the rounding to the fixed number that we want of digits to the right of the decimal point and spit out a number instead of a string if we want the expression to spit out a number instead of a string. So using toFixed, but realizing that it spits out a string may be a better way of converting numbers with large numbers of trailing digits to the exact decimal point that you want. The next section on imprecise calculations is also very important. You probably are aware of problems converting decimal numbers to binary numbers that the computer understands, such as why does adding 0.1 plus 0.2 not equal 0.3? In all languages, when you do this calculation and you ask, is that equal to 0.3, you're going to get false because that decimal representation of 0.1 and 0.2 does not convert cleanly to the binary ones and zeros that the computer can understand. An analogy would be 1/3. That doesn't convert cleanly to a decimal number. Even though we understand 1 and we understand dividing by 3, the 3's go on forever. And so that's what's happening here when we convert to a decimal number to a binary number and back again. And so you're taught in school different ways to handle this particular problem of dealing with decimal to binary conversions and how to deal with these trailing numbers behind the decimal point when we convert back to decimal. And there are 2 ways to handle this. And I had always been taught the first way, but in this little lesson, he shows us how the first way is not always correct. I had always been taught to convert your decimal numbers into integers and then divide by whatever number you needed at the end to put the decimal point in the right position. And so this little exercise, I've got a whole YouTube on it, is what I'm talking about. If we take 0.1 and we add 0.2, we don't get 0.3. But if we first convert them to 1 plus 2 and then divide 3 by 10, look, we're getting a correct number. So it appears that if we merely convert our numbers with decimal points into integers before we convert them back to the correct decimal point at the end, we're going to get correct answers. And I always thought that was true. But then our brilliant author gives us an example here where it's not true. Here we have an example where we have 28 cents we're converting to 28 and 14 cents where we're converting it to 14 and then dividing by 100 to get it back to cents. And look, we're getting a trailing number. That did not work. So when we just look here in the console, when we multiply 0.28 by 100, already we've got problems. But it doesn't always work to take our decimal numbers and multiply them to make them integers before we add, subtract, multiply, or divide them. And then at the very end, moving that decimal point back to where we want. That doesn't always work. But good news, he does teach you a way of making it work. And again, it's with the toFixed method. Let's say we have a variable and we're assigning it to that expression. He is teaching us how to correct that. So at this point in time, number 1 is a number with all these trailing zeros. But if we take number 1 and we assign it to number 1 toFixed, now we're back to the number of digits to the right of the decimal point that we want. And if we take that number 1 and we assign it to the positive value of itself, now we've got a number. Let's try that whole thing again in one fell swoop. Let's declare another variable, we'll assign it to a bunch of numbers that may end up not converting well from decimal to binary and back. We're not sure. But to be sure, we're going to wrap that whole expression in our toFixed method. And we also want a number to come out of this. So we're going to put a plus sign there, or we could wrap it with the number method as well, just to be super clear about it. And now number 2 is the number that we want. So you're going to see things like this in your code, and you're going to want to know why toFixed 2 is being applied. toFixed 2, that method, is being applied because whatever's in the expression may not convert to binary and back to decimal cleanly. We may end up with this really minor but annoying trailing digit. toFixed 2 is going to remove that using a rounding operation, and number or a plus sign in front of the entire expression is going to take that back to a number. The other really important part about this lesson is the parseInt and parseFloat methods. Those are methods of the window object. And where those are often used are when we're declaring a variable, I'm going to let value 1 be assigned to prompt enter a number. When I run that, I'm getting the prompt enter a number, and I'm going to put something in there like 3.33333. And so now value 1 is going to be this ugly number. Instead, let value 2 be assigned to parseInt of whatever somebody puts into the prompt. Then when some joker does something of this nature, then value 2 has automatically been converted into an integer, 3. And there are several other good examples of using parseInt with a number and some text behind it, which pulls out just the integer portion of that entry. And that would be in the case where somebody enters something like this, 3 ABC space, space, space. If I click OK, then value 3 is going to just be parseInted into the integer portion of 3. ParseFloat works exactly the same way, except it gives you a decimal number. If we used a parseFloat instead of parseInt, and I entered 3.5 XYZ, then I'm going to get 3.5 out of that instead of 3.5 XYZ. So it's very helpful. parseInt and parseFloat are very helpful anytime you're grabbing information from a user, because they can pad behind that entry with garbage text or just numbers that you don't want to use in the calculation. In summary, this is a great tutorial. Be sure you study the portions on rounding, imprecise calculations, parseInt, and parseFloat very thoroughly, because you're going to be working with numbers a lot in JavaScript, and this tutorial will help you keep your numbers under control and accurate. Thank you.